mecha wet chemistry experiment and the mecha microscopy. And we can choose to do those in any order that we want to. Again, our process is flexible. So at the moment, the first soil sample will be, in our plan, will be delivered to the mecha optical microscopy station. Excuse me. But as I mentioned, since our process is flexible and as we learn more information, we may decide to change how that works downstream. So I think that was all I wanted to say about that, and I'll give it back to Sarah.
All right. Okay, we'll go to questions first here in Tucson. As always, please wait for the microphone and state your name and your news organization. Andrea?
Hi, Andrea Thompson from Space.com and Space News. Was MECA originally scheduled to be the first instrument to be delivered to, or was that affected by the problems with TIGA?
Shall I answer that, Sarah? Okay. Okay. So yes, we did have TIGA in the plan, but we want to make sure that TIGA has adequate time to address their issues, and so we wanted to make sure that we don't slip our overall plan, so that we just rearrange things to accommodate.
Up here on the right, Leo. Kevin there.
Leo Enright from Irish Television. I have a related question and a follow-on, if I may, for Bill Boynton, I guess. As I understand, TIGA does a range of things, baking and sniffing in various orders. Can you explain where this ion source comes into that process? And can you say whether this affects the other geochemistry in any way, the MECA experiments, or is that entirely separate? And then I had a question about the dig and dump tonight. I mean, what time is that happening? And can you indicate where it's happening? It's obviously not going to be a national park, but I'm wondering where exactly is it going to be?
Okay, well, I'll address the first two. The TIGA instrument is completely independent of MECA, so there's nothing that we do that affects the operation of MECA. Now, the science that we get from the instrument is relevant to the data that we would get from MECA, and so they are somewhat synergistic in being able to reinforce each other. You asked about the ion source where we have the what looks to be a short circuit, and where that comes into this thing is when we're heating up a sample in the oven, we have a gas, we call it a carrier gas, that blows over the sample and actually delivers the gas to the evolved gas analyzer. The first thing the gas does, it goes into this ion source to be ionized and then accelerated by a high voltage to the detectors that actually allow us to determine what masses are present in this gas. And the problem there is in the ion source in that one of the filaments appears to be shorted out. We do, on the other hand, have two filaments, and the first thing we're going to be trying is to operate it with the other filament and see to what extent that may solve the problem.
Dave, do you want to answer the second?
Sure. In terms of the dig and dump question that you asked, actually tonight when we get the downlink, we will have the data to make the lander stability assessment. We need that before we do the interaction with the soil. So the first thing that we do actually before digging is just a touch test. We go with the robotic arm scoop, touch the soil. We will be ready to do that once we make this lander stability assessment from an engineering standpoint. The question is, from the science standpoint, are the scientists ready to interact with the soil? They want to make sure that they've completely imaged the site before we do the touch test, multispectral imaging. And so we'll have the debate in terms of whether the scientists are ready to do that or whether we need to go off and acquire more data. Sometimes the engineers say, come on, let's just get on with it. And sometimes the scientists say, we need more data. So we'll have that debate tonight. Once we do the touch test, then we do expect to go forward and do a test, dig, and dump, and then actually do a sample to deliver to the instruments.
Sally?
Hi, Sally Rail with Planetary Society. Either for Ray or Leslie, how soon will you go after this possible ice patch? Will that be one of the first?
Good question for Leslie.
Well, we're taking imaging data. The plan for this upcoming sol is that we'll take the imaging data of that during sol 6. But my understanding is that we can't actually reach that particular patch with the arm. So if it turns out to be ice or rock, we won't be able to actually acquire that particular patch with our arm. But we do believe that there's ice, a little ways below the surface soil. So it will be sometime after we get our surface soil sample, and then following on that, we'll start doing a trench, and then once we reach the ice, we'll be able to take a sample. So I can't say specifically when that will be.
Other questions? Alan?
Hi, I'm Alan Fisher with the Tucson Citizen. This question is for Dr. Boynton. The anomaly with the ion source, could that be related in any way to the moisture found during the flight to Mars that was resolved in the TIGA instrument?
No, those two things are completely independent. The moisture that we saw inside the instrument on the way to Mars and that we were very successfully able to remove is really a completely separate issue, and that essentially went away just by virtue of the times we baked out the instrument, essentially baking it out using a heater that was designed just for this problem.
Leo, another question here?
Thanks. Leo Enright from Irish Television again. I'm sorry for pressing this dig and dump thing, but could you just be a bit more precise about timetables? I know that's difficult, but will there be some touch test tonight? Will you be touching the surface tonight? I got the impression that you were talking about. Can you explain the sequence and the timing a bit more precisely?
I think I answered that as well as I could. The issue is, do we have the necessary data set for the science team to evaluate the composition of the soil so that we have all the information before we interact with it, and then we can do a comparison before and after. Maybe, Leslie, you'd like to talk about that comparison? Or?
Well, yeah, right now there's a debate between two different locations on the surface, and so we don't have enough information to decide which one will be a better location, or even if we want to go ahead and study both locations. So tonight will be the first, hopefully in today's downlink we'll be getting the first information on the first location, and that will guide us for the future. So yeah, I mean, again, our process is designed particularly to be flexible so that when we receive the downlink we can make choices responding to that. So that's one of the reasons we're not able to be very specific about how we're proceeding.
Well, Leo, the idea here is to keep the work volume as pristine as possible, and to think very carefully about what we're going to sample first. I mean, there are issues. I mean, if you do a dig and you then raise the robotic arm and you move it somewhere else, you're going to dribble some of that soil onto the surface. So it's likely that the dig area will be close to the dump area after we do the touch. We do a touch and then do a dig and dump. But we're debating now exactly where that should happen so we preserve as much of the work volume as possible without contamination.
All right, if there are no further questions, as we sign off, let me, on behalf of the entire Phoenix team, send well wishes and safe travels to our friend Commander Mark Kelly and the entire crew of Space Shuttle Discovery as they prepare to lift off tomorrow for a rendezvous with the International Space Station. And because of the shuttle mission coming up, today is our last televised Phoenix briefing until at least Tuesday. So please watch the websites for information about upcoming briefings and for mission updates and new images. And have a great weekend.